Morning. Today I'm gonna explain about lab 7 and lab A. That is a pendulum lab and the pendulum labs here. Okay, let me show the manual. Here is a manual is like this. Yes, and this manual is the pendulum labs introduction. A simple pendulum consists of a mass called bob connected to the end of a suspended cord or string, like this. Then I think this concept is related to the chapter 6 energy and oscillations, but we didn't treat pendulum in that chapter. But let me explain simply about that. Okay, let me show this. This okay. Now, okay. So this is a lab 7, 8. This lab will be done throughout 2 class hours, and there's a pendulum labs. Just simple. This pendulum is the ceiling and suspended thread or string here. Then there is a bob. Then this will be oscillating like this, back and forth, because of gravity acting on this object. Gravity is acting this direction, and here is a tension force. Then this some resultant force acting this direction. This can make this bob point this direction. That is, this kind of force is called restoring force. Because of this restoring force, this bob can oscillate like this, back and forth. And in this case, we have to know that is there are 2 frequency specifying some oscillation. There's we learned in chapter 6. In chapter 6, we learned there is a frequency usually written like F. F is just how many time oscillate, the number of cycles per unit time. Then unit is just the unit is 1 second inverse equal 1 hertz. This is a hertz. Yeah, this is the name of a rental car company. Is exactly the same, hertz. And also period is usually written like this, T, and period is the time for the bob to complete one cycle. As a unit is of course second, 1 second. Then here is the relation between frequency and period. Is frequency equal to reciprocal of period, like that. Period is also reciprocal of frequency. This kind of formula there. Then usually, but for pendulum case, this can be derived by using calculus. But this subject is not for calculus-based physics course. So I'm gonna just write formula. Formula is equal to T equal to 2 pi over L over G. Right? This is written in our here. Our manual written there. The formula is 2 pi t equal to 2 pi L over G, right? L over G, right? 2 pi L over G, maybe here is written capital letter, capital L over G. And frequency is also the reciprocal of that. This frequency is 1 over 2 pi times L over G. Here is what is L? L is length of the thread, yeah, thread or maybe string, the thread, and that is maybe meter or centimeter, yeah, whatever you may use, maybe centimeter or meter. Yeah. And maybe in this case we use centimeter. And what about G? G is acceleration due to gravity. Acceleration due to gravity. And you have to use 9.8 meter per second, but we can use 980 centimeter per second squared because we use the centimeter unit. Then we have to verify this kind of statement too by using this. In this case, you can see here is the period. Period depends on length of the this, this length is L. Only depends on length and acceleration due to gravity. It doesn't depend on mass, but also it doesn't depend on amplitude. Yeah. We're gonna check this kind of statement through this experiment. Sorry. Then come back to our manual here. Is we have the complete. Also through this statement, we can find the acceleration due to gravity. Yeah. Okay. So what do we need to do? We have to complete this table, first table. Let me access the simulator. Simulator is here. Here is, I wrote to. Here is, you can click there. This one, I can connect this. Share screen, yeah, right? And sorry, dropped something. Okay, so lab. We're gonna choose this one, then just to click lab. And what we need to do here is mass above is just above 15 degree arc, and then 100 centimeter strings. First we set this 100 centimeter. Then let me copy this table. I'm gonna do only 3 stops. Maybe I'm not sure 3 stops can do or not. But yeah, 3 stops. Yeah, you can do all of them, but it takes time. Yeah, so I have to copy this one. And table 2. Table 2 is table 3. Table 4. the last thing is something like we have to calculate the and experimental value of G and theoretical value of okay. And now let me explain and how to do this one. This one actually gonna do a cycle just 100 meter. Yeah, L should be 100 meter case. We have to see L is 100 centimeter, not 100 meter, 100 centimeter. Then let me check the simulator. And then you can see here is 100 meter. The length is, we have to tune this 100 meter, and then ruler shown here, a stopwatch, maybe stopwatch we need. I mean, you may use a period timer. But yeah, it's easy to measure period. But in this case, we have to do how many swings per minute, how many swings per minute. We have to find how many cycles per minute. Yeah. How many cycles? Then we have to check first point to 2 kilogram, point 4 kilogram, 0.6 kilogram. We're gonna do, let's see, 0.2 kilogram. Then mass should be 0.2 kilogram. 0.2 kilogram, and there's 9.8. No friction, no air friction. That let me check. This angle should be, angle is we have to know here is angle. What angle is it? 15-degree angle. 15-degree angle. 15-degree angle. 15-degree angle. 15-degree angle maybe. This is ready. Start. Just we have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19. Sorry. Sorry, that's counting is wrong. Sorry. You can use simply use just a period timer, but read it just 15 degrees, 15 degrees maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 12, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, just 31. Yeah, we can see 31. Yeah, you can count better than me. Sorry, 31. That's the, you can write it here. We have to write here. 31, 31, 31. Then per minute, then we can find the frequency because we know frequency can be number of cycles divided by 60 because 1 minute is 6 seconds. 1 minute is equal to 60 seconds. We may use 60. Then 31 divided by 60 that by using your calculator. Oops, my calculator. My table is messed up. Okay, here 60 divided 31 divided by 60. 31 divided by 60 can be 0.51, 0.52. There's, you can see here is 31 divided by 60 is about 0.517. That is 0.52. Then period is, as I said, the reciprocal of frequency. Reciprocal of frequencies. Then 1 divided by 1 divided by 0.25166. What is it? 31 divided by 60 equal to that 1 divided by that 1.94. 1.94 second. This is hertz. 1.94 second. We can see another one, 0.4 kilogram case. We can come back to we have to change mass. Yeah, this case, and then we're gonna measure again 15 degree. Maybe start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Yes, just 31. We can see, oh, it's the same, 31, yes, 31. 31, that's the same, 0.52. I guess this is, yeah, as I mentioned, this only depends on the length of the, it doesn't depend on mass of the bar. Yes, you can check this kind of statement by doing yourself. And that this is you can simply check period hard way, how to check period, and you can use just without this thing count 50 degree, and then you can use period. Yeah, 2.01 per second, 2.01. 2.01 is a little bit different from ours. Yeah. Anyway. And then the next the table is like this. The next table is this one. Amplitude. You're gonna change amplitude. Amplitude. How do we get amplitude? Amplitude will be measured, and as I explained here, amplitude will be here. So in this case, this time hold all the variables the same except amplitude. of the bulb. Then in this case, we can use something 0.2 kilogram. Mass, yeah, just use 0.2 kilogram. Amplitude will be measured by just, you know, this can be amplitude. Yeah, amplitude will change. Amplitude, we have to use some, what kind of value? We have to check the arbitrary value you may use, but here is just amplitude. We have to see how to get the measure amplitude. The ruler, additional ruler there. How to get that change amplitude? That by using just controlling angle, you can find the amplitude. Then we have to see here is maybe this timer is moved there. Then actually, you know, this good way should be this rotate, but cannot rotate. No way to rotate, but we have to use trigonometry. Trigonometry test. We think just to change the amplitude, then 8 degree, not maybe 16 degree. We can use the one there. Yeah, what kind of angle we can use. Then it depends on, as we see here is this angle. If we think this angle, then we can find this amplitude equal to this length. In this case, we can use 100 centimeter times 100 times maybe sine angle. Then we think first maybe 5 degree. We may use, then 10 degree, 15 degree, maybe 10 degree, 15 degree. You can use 10 degree, 15 degree, 20 degree, 25 degree. Then in this case, maybe 100. We may use the 10 centimeter, 10 degree. 10 degree case, 100 times sine 10 degree equal to 100 times sine 10. That can be 17.36 centimeter. Okay. 17.36. Then 100 times sine 15 degree case. 25.88 centimeter. 25.88 centimeter. May use this one. Then what about 100 times sine 20 degree case? 100 times 20. 34.2. 34.2. In that case, 100 times sine 25 degree. 42.226. Yeah, you may use your calculator this year. How to get that? We can use this one. Then you have to measure cycle per minute. Similarly, then first we have to do 10 degree case. This is a 10 degree case. 10 degree, 15 degree. That's 20 degree. The 25 degree. Yes, then we can use this one. So we have to see what the 10 degree. Ready, start. Just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, yes, of course, same, 31 here, 31, just the 31. You can see this is also same, 31, 31, 31. That is also frequency also similarly. If we test 0.52 second, then period will be 1.94 seconds. Yeah. You can similarly do this kind of work when by changing angle 15 degree, 20 degree, 25 degree. And the next table is when we changing the length, what happened length. That is important statement. Then actually here is we can see the length really related. And here is for this time hold all variables same except the length of the pendulum. Recall that the length of the pendulum is not just the length of the cord. The length is measured from the pivot point of the pendulum to the center of gravity of the bob. And the measure of the number of vibrations for exactly 1 minute. Repeat for 3 trials for each length. Average the findings and record all the data 3 from average data. You have to see. Data table is 3 and data table is 3. You have to 50, 60, 70. Now I have to change the length of the that. This is also exactly same to the. We have to mass of the bob is same. Just we can use a 0.4 kilogram, maybe either way. Right? Then we have to use a different length. Different length is 50, 60, 70. 50, then you have to change it 50. First 50, 0.5 meter. And then angle is maybe same angle. Maybe we have to use 15 degree. You prefer, and we can ready start. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. I think I missed one. The 46. You can see 46. So let's see 46. 46. 46. And then what about 60 centimeter? We're gonna move to 60 centimeter. Then we have the same 15 degree. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 36, 37, 38, 39, 40, 41, just 41, yeah. You can see 41. Come back to 41. Yeah, we can see here gradually decrease, frequency gradually decrease, and 70 centimeter. You can see 70 centimeter. What happened? 70 centimeter. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, just 37, yeah. Okay. 37. Here is 37, 37. And now we're gonna calculate the frequency. Frequency is equal to the number of cycle divided by 60 seconds. Then we can find the 46 divided by 60. 46 divided by 60 equal to, that is 0.77 hertz. 0.77 hertz. That inverse is 1.3 period. 1.3 period. Then this is 41 divided by 60 equal to 0.68. 0.68 inverse of the 1.46. 1.46. And what about 37 divided by 60 equal to 0.62. 0.62. And the 1 divided by period equal to 1.62 second. But this is our calculated one. Calculated one. T is equal to 2 pi square root to L over G. Yeah, we know this one. That is the formula. That by using this one, we can calculate. This is a calculated one. This is a calculated one. Calculated one. Then in this case, G is equal to 980 centimeter per second squared. Then we can find the T equal to 2 pi times L is 50 centimeter divided by 980. What is it? We can find this 2 times pi times 2 times pi times square root to 50 divided by 980. Then calculate 1.4, maybe 1.4. Now my experiment always has error here for 2 seconds. Then what about 2 pi times 60 centimeter case, 980. 2 times pi times square root to 60 divided by 980. 80. 1.55, 1.2, 55, 55, 55, yeah, a little bit different. Yeah, experimental and the theoretical value can be different. That is kind of measurement error. And what about 70 centimeter case? 70 centimeter is 1.68, 1.68. Experimental and calculation value, or it might be different because yeah, actually I think my measurement is not something like precise. And what about we're gonna see here is time of 25 swings. We can measure this one, then square root period, and then time of we have this 25 swings. Actually, to grab it. This is okay. We're gonna see here's over table of explanation 3 result of describe application 1.3, and then what do we need to table 3, the average binding, to record all data in table 3. From the average data, calculate the experimental period you can do, and then use method Bob to make a pendulum 25 centimeter length, and 3 separate measurements of the period of this pendulum by binding and the time for pendulum vibrate 25 times. And so record this data is the second nearest 100 full swings. And in this case, we should use and in this step, we should draw a graph is a T-scale and L graph. We can draw by using Excel. I think, yeah, this is a little bit, that is my suggestion. This is that manually written strange, but we're gonna write the draw graph by using this data. Okay, this data is a length 50 centimeter, 1.42, 1.55, and not that experiment that we have to use. Okay, I'm gonna write the draw graph. How to draw graph. Oh, the lab manual is written there. You have to see here this kind of graph, L and T scale, the L and T scale graph. Let me open Excel. L centimeter, T second, then we have to see T squared, that's a second squared. Then we can see here L is as I wrote 50, 60, 70. Let me show. Let me show. Oops. This we have to see 50, 60, 70 centimeter, and then period can be seen here. Period is 1 point, oh, not this one, table 3. We have to see here, table 3.1 is 1.23, 1.46, 1.62, 1.3, 1.46, 1.3, 1.3, 1.46, 1.46, 1.63, 62, right? Is it right? 1.3, 1.46, 1.62. You can see here, this guy's here. Let me. You can use 5 or 6 values or values that we have to see how to get scaled. That we can scale it like and scale. What is that? 1.69. Okay. Then we have to draw L and T scale graph. L and T scale. How get? Then we have to choose this and this the two. Yeah, by clicking Ctrl and then you can then we have to draw graph. Graph has here is insert and then scatter graph. Why is this so very strange? You have to see why is it that. Yeah, you can see here. Here's I think this is T scale T graph. Why cannot draw graph? Okay, maybe this value, you can see. This graph L and T. This is should be linear. Then you have to find the bit. Add the trend line. Trend line that's linear bit. You have to use a linear bit. And then display equation on chart. Then you can use this one, display equation on chart. Display equation on chart. And we can see here this will be slope. This is just slope 0.46. Now let me copy this one. See. This is table, and then this is Excel graph. Then here's slope. Slope is 0.067, 0.467. Then as we see here, here you can see T scale KL. This T scale is like derive T equal to 2 pi over 2 pi times L over G. Then if we T scale can be 4 pi scale. If I take a scale both sides, then we can find L over G. Then we can see here is a T scale related to this. Yeah, this side the T scale. This is L. T scale over L. That is this is a slope. That is 4 pi scale time over G, right? That this case that slope can be 0.0467. Then we can see here is G. How to get G? G is equal to 4 pi scale divided by slope. Yeah. Then we have to calculate the 4 pi scale. 4 pi square divided by slope is 0.0467. Then by calculating, you can see here 4 times pi square divided by 0.0467. If we calculate this is 845, 36 centimeter per second square. This is much different from G equal to 980 centimeter squared. Yeah, this is our experimental value. This is theoretical value. Then we can find the error. Error can be G theoretical value and denominator and G theoretical value minus G experimental value, the absolute value times 100. You can find the error bar. And I guess you can measure better than me because yeah, my counting is clumsy. You said yeah, I mumbled there, and so I think the theoretical value is 980. That this can be 13.7%. Yeah, big error. It's, my experience not good, but you can do. I'm theorist, yeah, not good at experiment too, but you can measure better than me. Yeah, I think I made some mistakes in counting, right? I should count now precisely. Then the next one, this one is you can do by yourself. The time of 25 4 things. Then that's all. I think the rest things can be done by yourself. And thank you for watching this video. I'm gonna close this explanation here. And that's all. I'm gonna upload this one to announcement. Yeah. Okay, I'm gonna end.